So I'm going to keep the big data part brief because we've all heard it 6 times with all the presenters and everything. But we are going to do big data architecture. I'll give you my explanation in a second. So our agenda for today is what is big data architecture, impact on selection of technologies and development projects, current architecture available, and then Carlos is our Teradata specialist. He's going to talk about that later.
I'm also going to cover the preferred structure.
Next. So what is big data? And while doing this research, I wanted to add 3 more V's. I'll explain why. As we know, there's volume, velocity, variety, and veracity. And after this semester, I realized there's 3 more. Variability, which you guys can back me up on this. Basically, this is more text sentiment. We learned that in Python, certain words mean the same thing, and certain words have 2 different meanings. So the variability of data coming in could be the same or different. Visualization, when data is unstructured or structured, when it's structured, you can visualize it better than unstructured. You don't know what to do with it. So our definition of big data is any kind of information that could be gathered to solve a business problem. While doing this research, I watched a bunch of consultants talk about how businesses don't know what they're doing with big data. So the next slide, there's going to be a picture. Get all the information you can and we'll think of a use for it later. That's what I see big data in companies now. All of the CEOs and CIOs are asking their employees to get all this massive amounts of information. And they're really not sure what to do with it. So there was a talk on, I watched on YouTube that they were explaining that most companies want all the Fitbit information and all the Apple Watch information, all that. Nothing to do with it. They just want it. Because a couple of years down the road, someone will know what to do with it, and then they can catch up to it. So, next slide. So, we're good. Sorry, I was making sure the computer. So, our big data architecture is data used to be more structured than it is today, like I said. Unstructured data is basically social media pictures, video, like what Chris said earlier. And on the next slide, a couple slides, there's going to be the new generation of architectures as opposed to the old generation architectures. Go ahead, next. That's us swimming in big data. So my understanding of a simple big data architecture is raw data goes in, it gets processed, and then there's some kind of value attached to it that the end user could then see in a dashboard or something like that. Next. And then this is our modern next generation data processing and management. The only difference here would be that there was no big data engine before, now there is, and that's taken place by Hadoop. Eric,
yeah. Okay, so my name is Erin Mortensen. I'm going to go into a little bit about the different, deeper dive of big data architecture. So data architecture is the models, policies, rules, or standards that govern which data is collected, how it is stored and arranged, and how to put it in use in a database system or organization. There are many different components of this. There are file systems, which are distributed file systems that provide storage, fault tolerance, scalability, reliability, and availability. Examples of these include the Google file system and the Hadoop file system. Data stores is the evolution of application databases into polyglot storage with application-specific databases instead of one-size-fits-all. Data stores are classified on ACID and base stores, with base being further classified into key value, document, column, and graph, and ACID being broken down into Megastore, Spanner, Mesa, and Cockroach DB. Resource managers provide resource management capabilities and support schedulers for high utilization and throughput. Yarn is widely used to support Hadoop framework, and Mesos provide scheduling between multiple diverse cluster computing frameworks. Coordination are systems that manage state distributed coordination, consensus, and lock management. Examples include Paxos, Chubby, and Zookeeper. Computational frameworks are highly specialized compute frameworks for streaming, interactive, real-time, batch, and iterative graph processing. Powerful runtimes such as Spark and Flink come to mind when discussing computational framework. Data analytics are analytical tools and libraries which support exploratory, descriptive, predictive, statistical analysis, and machine learning. Data integration includes not only the orchestration tools for managing pipelines, but also metadata management. And operational frameworks provide scalable frameworks for monitoring and benchmarking. Okay. So the impact of big data, as analytics students, we view big data as a pathway to solving the problems for a business. Big data architecture also allows raw data to be processed, analyzed, and implemented to capture consumers based on their preferences and needs, and it creates more value for businesses. So examples of these were Capital One was one of the first people to really use big data. They started capturing the habits of their consumers, and they were able to increase their, I believe it was they captured 32% more users between 1999 and 2004. I had it in my notes, I just forgot to bring them up. Also, Walmart is a big user of big data. They obviously track all their users' behaviors and then capture their customers based on their needs and behavior. And Rolls-Royce was another really big one. They track their plane division, the engines they put on planes. They track when they are breaking down and when they need service, and that way their plane engines result in 72% of their revenue based on that tracking device system. So 64% of all IT leaders in the industries are investing heavily in big data. Investors have found that companies that are heavy on big data are highly valuable, not just for their data, the data that they have, but for their use of analytics as well. 75% of surveyed CIOs said that big data positively impacts productivity and efficiency overall. 69% of survey participants cite big data as critical or high priority, and 70% of the respondents state that their big data investments impact business innovation positively.
Okay, so how does this impact selection technology and developer as overall? So, I'm Lee. Hi. So it's dependent on the market size of the business. So whatever the market size of the business is, this technology is based on what it is. So let's say you're a small business, you don't have the cost to. You might well go for a free open source or build on it from maybe a basic. You're a big company, let's say like Apple, or they might have their own, or they use like something bigger. So they could use easily integrated with multiple infrastructure into one. And as I say, increased amount of data is because of big data, it's a big volume of it. The need for the new technology is on a constant growth, and a lot of programming needs to be created. And there's a bunch of them new, but they're not at the mature level just yet. So a lot of the infrastructure for big data is a combination of somewhat of the old and somewhat the new, and it's a mix of both. And that's why is it impact? Because it's hard to choose in between. There's no one core one. So as a base data infrastructure, as data infrastructure to solve is the issue of how much you can store an amount of data. This is very different by, as I said, among companies. You can be either big one or small one, but it's also an investment, or you can go with a low cost strategy, free or as investment. The main core of the infrastructure is to be resilient and it's redundant. Resilient is that because of big data is a disruptive force in the normal data set, resilient is that it can be used and honed to grow and to be updated easily with the growing database. However, the redundant part is that it has to be able to adapt to those and be still useful. Not just because it's updating, it's no longer useful, it has to be somewhat be able to still connect it with the old, maybe the queries, the system that's been built on. the ranges of those infrastructure that can be as a support are from the Hadoop, NoSQL, MPP to cloud. Hadoop, as it says, is an open source framework that usually based on Linux. NoSQL is basically not using the normal SQL anymore. MPP is multi-parallel programming, so that meaning it's a database that's running on a big scale, but at the same time parallel to other systems as well. And then you have the cloud computing. Cloud computing is at a very low cost in this style of infrastructure, and it's offered by if you have the top three, you have Amazon, you have IBM, you have Google, and you have Microsoft. Those are being paid to do so, but it's at a lower cost, at a cost of whatever the percentage of you using it for. The next is when you're building infrastructure, the computing power is needed. The big data itself is such a problem, but if the company does not have the power to be able to handle it, the data will break down. Basically, where are all this being hid? They won't be able to find it. So this is basically referred to a computer and analysis of the data. We require high performance computing, such as MapReduce. Under Hadoop is basically involve the big data, but break into pieces and analyze the small pieces, but then combine all at the end to get a bigger analysis. So some companies are implementing such as machine learning at a large scale and possibly artificial intelligence being used. When I'm talking about machine learning, it's learning from the data set, but it's also growing from the data set. It's learning through logically implying of whatever the data set's being put in through that's been processed and transformed under the either unstructured or structured data set. And under the artificial intelligence, it's actually a higher thinking of the machine learning. It's involved using human interaction and human thinking at a higher speed, but also at a higher level of computation. It allowed multiple variables, different paths, and different decision based. So it's the computing power at this level is kind of on what most companies who are investing in big data are pushing forward to. And it's one important key. And the last part of all of this is how is the company going to visualize all the data? How is it going to be interactive to as someone who's not an expert, or is it to an expert? As it says, a picture is worth 1,000 words. A picture can describe a lot of things. There's a lot of insight to it. Visualizing data to, as I said, how the message convey it to someone. Let's say if we're not an expert in this, you have to be able to explain it to us. The company has to explain to us so that we can understand it. Such as, some simplest ways, data dashboard, interactive, visual, and are some of the ways to do so. And as such, there are some architects that are in existence, which I'm going to lead it off to Carlos.
Thank you. I'm going to get you the fun part now. The data. Just get the data. Let's bring on the data. Show me the data. I'm stalling. Anyways, right now, there's a lot of different kind of architectures out there currently available. The major ones, as we all know, I guess, as we've learned in this class and other classes, Oracle, one of the originals of SQL-based database management systems. They may know for their one of the leaders, and we actually started in one of our classes. Then along came Apache Hadoop, and their biggest thing is the way the file system of MapReduce uses to collect all kinds of data. They're a data lake, not really a database, to collect everything you can think of under the sun and make it available for any kind of system to use. There is some, of course, complicated ways of querying or getting the information from there. You have to be based in Unix or some other JavaScript languages out there. So you kind of have to be an expert how to be able to get the information. And then, of course, we have Teradata. Teradata really is a company that actually, their system is called Teradata, but it's actually a company. They came up with it's kind of a combination of database software and database warehouse system. It's kind of unique, and I'll talk more about that because it actually uses that work. One of the biggest things about it, each node has its own memory and processing power, and I'll speak more about that. A little bit about Teradata history. It actually started from a conversation between Caltech and Citibank. Got some students who were really brilliant. Citibank said, we have a question, we have a business problem we want to solve, and Caltech students were very smart. They're like, oh, let's take a stab at it. Guess what? They thought we have a great product here. So in 1979, the same students, along with Citibank Finance Incorporated, Wells Fargo, which I don't know if they're still around, was the first one to try out the beta system as far as Teradata. And the first 1 terabyte system went live in Walmart in 1992, no surprise to anybody here. And most recently, Teradata has started focusing on the analytics of things, which is related to the Internet of Things. Is everybody familiar with the Internet of Things? What we're talking about? Just in case you don't know, everything's going to have a sensor in the future. Your refrigerator, your car, your TV, your lights. God help us, maybe even your bathroom and your toilet. Who knows?
Oh,
Anyways, for health purposes only. So we need a lot of, this would be, think about that. How much data we're producing now? Now multiply that in your home by 1,000 sensors. How much data that's going to produce? How do we read this data? How do we manage it? How do we access it? How do we file it? That's kind of what they're working on right now. So I'm going to go a little bit to the infrastructure of holistic structure, how Teradata works. And then I'm going to go into the internal and how the end user experiences. And I'm going to give you actually a demonstration of Teradata query and also what a warehouse table map looks like. Pretty cool. As you can see, you have logistics, call centers, customer suppliers on one end, executives, products, finance, markets on the other end. You have the operational intelligence being pulled in by this side, and then you have the strategic intelligence trying to make sense of it all and develop strategy for your company. So this is information flow that goes back and forth. And it all gets processed by an active enterprise integration system. It could be anything, we can go into that later. It could be a POS, it could be an online survey system, or whatever it is, it gets integrated to that. It gets pulled to Teradata system. And here is where the processes are, I can go into that. You have the active load, that means it's always loading actively, depending on your POS system, or whatever it is your company does. Active workload management, it's always managing the system. It never shuts off. So there is no off button where, oh, we're off on Sunday, doesn't work. Your customer, or whoever the consumer is, accesses it, whatever system you're using, it will be integrated, it will be recorded, it will be loaded. And then active availability, very important. I need information for Monday's meeting. I can't wait till Monday for the warehouse to open. Unfortunately, since I have to do it on Sunday, pull up my Teradata and pull up a report. It has to be available at real time whenever I need it. So that's kind of a holistic overview of how it works. Now, internally, this is what happens. So, one of the biggest strengths about Teradata is its processing, its parallelism. It works in parallel. It makes it faster. Imagine two highways are open at the same time. The primary source is the parsing engine, called PE, binary framework, which I can go into later, and the AMP, Access Model Processor, this little guy right here, which each have their own read and write disks. And the cool thing about this, they can only read and write to their own disk, so there's no accidental overwriting of the data. Now, the way it works internally, the PE submits a query, right? You submit a query as a user. PE takes a query and says, okay, how do I want to get the data? He organizes data, thinks, this is what he wants, where do I get it from, where's it at? He organizes the query basically, and then communicates to the app, tells the app, hey, this is the result that I want, give me the information. It's also called the optimizer, by the way. Now the app listens to the PE by way of the binary instructions, and then okay, this is what you want, let me see what I got, and then I'll upload it for you, I'll write it for you in a nice little format, whatever you want, Excel, whatever format you want. Think of a computer processor with its own little disk. That's kind of how the apps work. And then the Binet is more of a just basically a communications framework. This is the guy that kind of communicates between these two guys, right? He kind of gives them like, hey, P, AMP, when P wants this, AMP says, well, here's what he wanted, and it's basically what it does. There's always two Binet systems, by the way. Binet 0 and Binet 1. Does anybody want to take a gander at why we always have two systems, communication working? Anyone?
Just in case it goes down.
Thank you. What else? Faster. Right? Lincoln Tunnel, very good, yeah. One goes down, guess what? We're still talking, still communicating. So that's what it was like. We just say Binet network system, but there's always two running at the same time. Now, here is the end user experience. Like I said before, collection from various sources, multiple points of access. What I mean by that, anybody can use it. Data analysts, marketers, data miners, data scientists. Anybody get the data they want from the same source and sources. You also have, people who have access to the system are able to use queries provided for them. You don't have to know SQL. I'll give you an example of what I'm talking about. But if you have a deeper foundation understanding, a fundamental understanding of SQL, you can modify a query for your own needs. The one thing you cannot do as a user, though, is update the tables, change the tables, or God help you accidentally delete the table. So that's protection against that. You have a core team that maintains the tables and limits access. They're the ones that go in there, make sure that it's nice and smooth, it's going where it's supposed to go. And if we need a new table, they're the ones that go there and create it. And if we don't need another table, they go in there, make sure there's no data that we need, and delete the table. It also has us upload to applications, like we can have marketing applications, CRM applications. You can upload the data directly to these applications. They're actually referred to as cubes. A cube, think of it as an applet. Like a dashboard. A dashboard is actually a cube that pulls data and gives you visual. It kind of manually does it without you having to go in there and pull data, create a spreadsheet every day and make it nice and pretty. It's an automatic way of just data getting pulled every day. So you pull up your screen, you see the numbers, or whatever it is data you try and find. Any questions about this user experience? Okay, so I covered what kind of how Hadoop works, the internal workings, and the user experience. Now, I'm going to give you a really cool example of what Teradata looks like. It looks orange. No, it does not. I guess nobody liked that joke. All right. Delete, throw that part away. Okay, so this little guy right here at the bottom, you can see the arrow is, I click on that, and this is my Teradata screen. I go back here, and look for my query, which is right here, and I just drag it, and throw it in there. Now I can go in there myself because I'm familiar with Teradata and modify some of these fields, change some of this stuff in here if I wanted to, but I'm going to run into this. All I do is hit here to run, execute. Oops, I want this. Okay. Okay. There we go.
Now
The little circle is working.
access.
Can be running a little slow.
The program crashed.
Okay, so then I put in my information. By the way, you guys ever get to my work, you guys know how to get into my Teradata system. I put in this case, I'm looking for some information from a certain date. 0509 to, oh, by the way, the first part of the year, 0509, we'll keep it to one day. It'll start executing, blah, blah, blah. It runs, and it'll give me a nice little column of data, which you can now then transform into an Excel sheet. So I just want to give you that example. Now, brace yourselves. This is what our internal data warehouse looks like. Okay, so I'm going to get a little closer. These are all tables. This is all the structure of our warehouse. So all the data is. So all tables. So I'm going to get a little closer.
Oh, this looks much cleaner than
You guys remember these little
some really bad
connections? Child, parent, user ID table, month revenue table, customer account tax charge table. I mean, you name it, we got it here.
What normal form?
So, see, if you want to know what table to look for, you just have to find the right table, and then you can just look at the data you want.
Just gotta find it.
Yeah, for example, if I needed to go, oh, computer's still down. Anyways, I want to show you guys what a map looks like. So, let me go back to the presentation. Was that pretty cool or what? Woo! I thought it was when I first saw it.
Don't show me again.
Now I'm going to talk about preferred structure. Why? Going forward, Teradata is great. It does have limitations. It's very structured. It's kind of old in a way. I believe the preferred system. Now, keep in mind I work for a big company that has a lot of money.
Not on stress.
Well, that's a lot on side. Anyways, so this is the system that I'm gonna advocate for is not a cheap. It's not a poor man's system, unfortunately. It's an established company. It's a big company that wants to do a large amount of things, especially with the internet things coming on board, which we're big believers of and proponents of. Now, this structure is called the Unified Data Architecture. It's a combination of a couple things. You have your Teradata system, analytics portfolio. You have your Hadoop file system, data lake, access points. And you have a new, what's called Teradata Aster Discovery Platform. Teradata Aster is a new platform out there that it can help you basically with all kinds of data, audio, text, images, web, social, machine logs, CRM, whatever you can think of. It does it all. Basically, the mentality is give any user any analytic for any data. That's what the purpose of this structure. We all know the challenge is extracting and integrating data and getting value from it. So the way this does it, it creates two platforms, one for exploring and for mining purposes, which is here, and one for the Linux manager reporting, which is over here. And the data is collected here. And the cool thing about Hadoop, as we all know, collects data from any source whatsoever. Now, why? Because like I said, it integrates two platforms. That's why I believe it's a great source. Teradata Portfolio, Teradata Aster, and Hadoop, and then the warehouse. It has transparent access. In other words, anybody can use it. Anybody can go in there, get the data they need. Seamless data movement. You don't have to be an expert. I don't want to hire a bunch of SQL database managers, a bunch of Hadoop experts. That costs money. I want my business analyst so I can pay for cheap to be able to just go, hey, BI guys, I need a query for this, this, and that. I give you a query, you drag it, like I showed you, click it, run it, get my information, and pull it in. It also provides for single operational view for management. Management gets the information in a nice visual, anything they need, they can get provided from. My big boss comes to me, Carlos, I need to find out, back in December of 1819, Best Buy had a promotion for a $1 iPhone. I want to know what happened to those phones. Are they still active? Was it fraud? How much money they lose? How much money they make? What happened? And I can actually do that using the system. Actually, that's one of the prizes I was assigned, as we discussed in Dr. Romero's class. One time I asked him for some advice on that. Now, oops. I'm going to give you an example, okay? Say a global communication service provider, just say, random, wants to improve performance by learning about the customer, right? Customer experience and network performance. They want to improve the network performance. So they want to deploy their DPI, which is basically their deep pocket inspection tool. And how would a company go about doing this, right? Well, the way they would do it is Teradata will collect all the data, right? They would pull the customer information, the usage, whatever. The data would get pulled into Hadoop. Teradata would integrate all the data, file it, filter it, condense it, enrich it, whatever it has to do with the data. Transfer it over to the Discover platform where we can actually do the data mining and use all the analytical tools that Aster provides to give us some kind of information. So some of the results we get, we can find out, problem spots, comparison of 3G versus 4G performance, potential problems with certain devices. Some antennas are better than others. Like identify fraud. We can find, we can delve deeper into customer behavior. So there's other things we can do about that. That's one of the reasons why I believe that this is be one of the best systems out there. It's kind of a combination of everything you want. Data warehouse management system, which is simple, your analytics platform, which is Aster, and of course, your data lake, which collects anything you want. So at this point, is there any thoughts, concerns, or emotional outbursts you want to bring up? That was the conclusion of our presentation. Thank you very much. So no questions?
The answer all, thank you. So, Teradata answers all of it?
Yes, it's expensive. Oh, by the way.
How expensive is it though, honestly?
Okay, I think of 300 billion bytes at half a K.
Is that in dollars or pounds?
Dollars. I think the biggest system right now is a 4 trillion byte system that Federated Storage uses. It's a 14 trillion byte system that Federated Storage uses. For example, I think Verizon, when they first got it, I think we paid almost like, I want to say almost $2 million for installation, everything, servers, whatever. Now we maintain about $20 a year. We maintain the system.
10 million to maintain.
2 million.
2 million to maintain. 13 to 10 to implement.
Well, I don't know how much data we process. I would just example was 14 trillion. That was actually Federated Sons, which is the parent company of Macy's and Blooming. Yeah. So, oh look, here's my result. My Teradata right here.
Oh.
Cal date.
Oh, so you're.
Outlet ID named here.
Yeah.
So.
Wow, that's nice. Can't afford it.
Yes, it's not the poor man's system.
I'm not a poor man though.
But
We're
one thing
data
about this though,
analysts.
one thing about Teradata is, is security. One of the biggest things for Verizon is security. That's why we can't use a lot of open source stuff. We just cannot afford to have customer we'll call CPA 9 need to be
I think
compromised.
most large companies are in that situation. What does the market share look like in terms of Teradata versus HP versus Oracle versus?
Well, it's not anywhere near as much as Oracle right now. Hadoop is a different kind of platform, so
Yeah, it's more open.
but Oracle and IBM have the largest share, but it is climbing fast because one of the things that people are starting to notice about Teradata, can handle vast amounts of data way faster, more efficiently than IBM or Oracle. They just cannot compete when it comes to the speed and the amount of processing power that Teradata provides.
Yeah, because
For price.
IBM and Oracle have kind of enhanced their, previous versions of databases.
To try to keep up with them.
Database, right. This is out from scratch.
Yeah.
Teradata is easier to use too.
I'll give you an example.
That's why it's a simpler
I'll give you an example how another simplistic way of explaining it. When I was growing up, right, my mom spoke Spanish, went to the school, and the school administration only spoke English. I speak both. My mom would ask me. That's one thing about SQL, by the way, I forgot to mention. Teradata Astra actually uses SQL queries, but it doesn't go to Hadoop and use SQL. It uses language SQL uses. So like my mom would ask me in Spanish, hey, how are your grades? I would ask the school administrator, not in SQL, but in English, whatever language SQL, Mr. Teacher, how are my grades? I got a D. So then I got to take that grade, process the data he just gave me, and then translate it to my mother. Mom, he says I'm going to pass the class. So that's kind of how it works. So, it does use SQL to query data, but it doesn't talk to Hadoop in SQL. You can use any language you can think of. I'm not sure
how big is the Teradata market right now?
Oh my God, I want to
of the total?
say that's one thing.
It's growing, because they just opened up the Teradata Astra is the newest.
This new version.
iteration of it, so it's
And-
actually easier to use, so people who aren't trained in SQL could actually use it as well.
And like I said, they're already planning for the Internet of Things, the analytics of things. And Oracle and IBM are not quite there yet. They're still trying to, like I said, enhance their systems to keep up with the current data.
I would say
When
about
this happens in the next
5%
few years.
market share, about 5, because as we mentioned, it's a growing one, but it's also, as you can see, that it's an implemented system that's used multiple different infrastructure. Like I said before,
And it's
it used an
massive.
old, but it's also applying new technique into this. So like SQL was involved, Hadoop was involved, but Teradata as a whole is actually something new, but it's very easier, but at a higher cost for certain data structures for safety in these certain technology-based labs.
Then, questions?
Oh, there was one slide about investments where there was a chart with percentages. Is there any way to, I was kind of curious about that, just sort of an interpretation on some of those costs. I know that was earlier on in the presentation, but I was really actually curious about that, just kind of getting a better understanding. It looked like survey data, or I'm not sure which slide. It was like slide 4, 5. We was talking.
I think it was
about
slide,
architecture.
yeah, I know what you're talking about, that's slide,
But I think it's, I thought that was pretty interesting because we were talking a little bit about some of the cost implications and some of the other sort of
I have it up more.
some of the considerations that come into play, and I think that's an
What slide was
interesting.
it?
So
It was in the beginning. It was.
It's talking about the investments needed for the data structure.
Yeah, there you go. Yeah.
So it's investments needed for the data structure.
So I see a bunch of percentages. What are these? These are based on surveys. These are feedback. What are we talking about? And
These
what's
are
this-
based
what's
on
this-
surveys. These are surveys feedback from multi-corporations that are looking at the infrastructure to rebuild their big data one. It's like the big, and most of it's a Fortune 500 one. So there's like a lot of using is so existing resource on big data technology. So SQL, Hadoop, or any of kind of those infrastructure database, they're being put back into research and using the old technology to somehow implement with the new one under improving Oracle database and stuff like that. Then the other one's new
Actually,
infrastructure.
wait, just to understand like the percentage. So this is based on surveys. So we're saying that 57% of the respondents indicated that was their top
Yeah.
expense,
Mhm.
or that was an expense.
It was an
Yeah,
expense.
I think you guys were presenting it like those were the, 57% of expenses instead of 57% of the
Survey.
survey, survey people thought
it's
that,
fi-
that this was the highest.
If the
expense.
survey says that they're investing in to rebuild,
Or
so
the need, I guess.
so it's the need, so probably is an investment under the research development expense, so like growing side, so it's considered expenses.
Are these the top concern from the surveyed applicants, or is there overlapping response for the survey respondents? Is it 50%? 57% of the respondents said that was their top cost, or that was their top obstacle, or was that just?
It was more like a need, like what's our biggest need, what's our biggest concern?
I guess my question is does a respondent fall in multiple buckets in terms of that particular survey
Good
result?
question, I don't think we didn't really delve into that. I think we
Yeah.
should,
I would say yes, because it's overlapping of all the surveys.
So
It's
is
not,
Does each just want to have one vote or multiple?
That's what kind of was going. I'm interested in the data is interesting, but I just want to just trying to get a good understanding
it's
of.
multiple vote, because it was asked, the list is asking what is being trained, their concern is what is the database is being trained for, the original one, the old one, and what is going to be the new infrastructure, what is there going to be invested in infrastructure. So what's a lot out of the company that was being surveyed, majority are focused on retraining and improving the old technique, like Oracle, SQL, and stuff like that, to help somewhat handles the big data. But
So it's not necessarily an implication of relative cost, it's more
Yeah.
of an implication of relative concern or impacts of the project.
What's
Yeah.
interesting is that 22% of people thought that hiring a consultant firm from a big data expertise
it's
was so low as
Right.
opposed to let's train our existing staff, which is
What
what
do
the,
from with
Well, that's why I was asking, that's another reason I was asking, because I would think that both of those would be important
Yeah.
considerations for a company, but there would obviously be a big difference in the cost of it, and those proportions might actually reflect the relative cost, because to retrain staff would be expensive, but at the same time, hiring a consultant would be expensive too, but it would probably be a much shorter term expense.
Well, another reason too, and it's from personal experience, that what we're developing our own big data infrastructure is domain knowledge. A consultant, for instance, has to get up to speed to what we do, and may not always have the domain knowledge of internal.
and if they do, they would be expensive.
Yeah, exactly.
But that does also kind of make sense to me, because if you're training existing resources or existing employees, those employees might have knowledge on the infrastructure that you're actually putting into the company, whereas the consultant knows for sure, but they'd rather train their employees rather than hire a consultant, because the consultant is going to be more expensive. And what the consultant's going to do is actually train the employees anyway, how to use the infrastructure and how to manipulate data and stuff like that. So
is it a priority that they would like to spend money first on training?
that's what I'm assuming, yeah. Because on the bottom it says there's no requirement for major
Well, it doesn't have to be a
investments.
monetary investment, it could also be a capital investment, like your training resources, technology resources, internal resources, so
So,
it's an investment need, like.
It's also nice that hiring new resources with required skills is that high
Yeah.
on the chart, because that's us.
Yep.
So then instead
Good
of
news.
Yeah, good news.
So instead of rather than go with a consultant, they rather hire someone with already expertise coming straight in from there.
the also, I mean, it's like the dot-com world, right? When it's a longer duration skill sets and the activity is just starting.
Right.
So there is a longer term investment, and that's why I'm not going with as opposed to Y2K.
Totally.
Temporary
expenses.
Which was all consulting.
Oh,
Which
yeah.
was completely 100%,
They
no
pull
matter
those
how much.
COBOL programmers out of the woodwork.
I remember that.
No. Jeez, Howard Hill made so much money.
Oh, yeah. I remember the.
Big contracts, yes.
Oh, yeah, where I worked, people would get their annual salary as a bonus if everything went without a hitch.
What?
That was very typical, right? That was very
Right.
common, right?
Did anybody really mess up Y2K and like destroy all their data? Like, we never heard any
There were
story
some
like
horrors.
that.
There were some horrors.
I know.
Because a lot of effort went into it.
Oh yeah.
A little side note.
That's why nothing happened.
I was in the Marine Corps at the time when that happened, and we were on standby. Every Marine was on standby, ready to go, because there was some kind of national people were on base up till 4 in the morning, geared up, ready to go, just standing around like.
I was doing production support at a oil refinery.
Oh, wow.
I was 13 in my bed thinking that everything was going to turn off.
I was in Vietnam getting ready to leave the country to come to the US.
Question about Teradata. You showed the SQL query analyzer tool. If I wanted to use Teradata for dashboarding, reporting, visualizations, or even some kind of analytics modeling, are there any other native front-end tools that I could use, and what types of skills would be required?
Yes, there's tons of, we call them applets or applications or cubes, if you will. There's, especially for marketing purposes, there's a lot of them. Obviously, my role is more of a numbers dive. So I do a lot with Excel, and I kind of throw in some of the tools I learned, like, I throw Excel into my, I like using a lot of Tableau. Which one is like I hired because I can't use Tableau. Anyways, but there are a lot of front-end user interfaces. It also depends, like how, like a finance guys they have, each team has their own, basically core team that manages the data tables. And most guys, they don't know how to use the system. They just tell the core team, this is what I need. So if it's an application, if you have the core team, depending on the application, the core team will go in there and pull the data, depending on what visual it is. Now, if you're
Carlos, let me rephrase. If I wanted to do analytics using Teradata, what tool would I use? Is there an interface for that?
well, there are BI tools, yes. I'm trying to think, like our strategy department, our department is actually called the strategy and innovation. I'm not sure what their interface is, but I know that they don't use, the query that I use, they don't use that at
It's
all.
not a native tool. It's not a native application. It's something that's customized or built on top of
It
it.
was customized,
Okay,
yes.
that's cool.
Because Teradata is very customized when it comes to that stuff.
Right. One more question. You mentioned cubes. Are the cubes in Teradata any different than traditional OLAP cubes from a regular database or data
I
warehouse?
don't have any experience with OLAP, so I would not know.
Right.
I would assume so because the guy that helps me modify my queries, because I want to learn, so I try to modify my own queries and I ask him when I screw up. Oops, I'm not getting the data I want. He's like, why don't I just create a cube for you? And he did OLAP before, so I'm guessing his experience with OLAP kind of helped him get the job. So, to be honest with you, I'm not sure.
Are you aware of any latency or delay sort of due to pre-processing based on the cubes for a Teradata installment?
I'm not aware of that.
Do you know-
But
do you know how-
like anything, you never know.
Do you know how recent your data is whenever you run a query?
Oh yes, it's like day to day, like
Yesterday or like
at
right now?
midnight. As soon as midnight's over, I can query the 10th.
Okay.
So because I've done that before, so I know how. It's active system, continuously upload. Or it's probably as soon as the store's closed and then it gets collected, but I've never tried that.
Okay.
I usually wait till midnight just to make sure, but I'm just being maybe superstitious, but that's when the day ends. In
So-
case Teradata gets confused.
So the querying interface, or whatever that is called, the editor, is it accessible to all users or it's only the
You
developers?
have to have
and-
permissions. You apply permissions depending on your role. Depending on your role, you will have access to that. Example, for what we're talking about, if you were into the strategy department, to get access to their interface, whatever you use, you actually specify, I need this interface access because it's based on my role.
But the end users of reports, like the executives, they probably have a different user interface, which is
Yes.
more GUI or
Exactly, yeah. Actually,
and selecting variables. and
my
stuff.
vice president that I deal with directly, he does not deal with any of this. He just
Yeah.
goes, Carlos, what happened with this promotion? I was in a lift.
Uh-huh.
John Kaluri, let me get back to you in 30 minutes. Well, usually takes more longer than that, but. So that's basically I'm his GUI, basically.
Yeah, right.
Yeah.
Cool.
Yeah, most people at the high level right now
Uh-huh.
do not know how to use any of this. My own manager, senior manager, he does not. When he asked me, have you ever used SQL? And I go, what kind? Oracle-based, non-SQL, SQL, or MySQL? He looked at me like, there's more than one. That was what he said. There's more than one. So I was like, oh, I got this job, cha-ching.
Promotion next.
Nobody had ever asked him that. Nobody even. Some guy asked him, "What's a sequel?" Sequel to what? A movie? So it is very complicated technology, but they're making it so much easier to use. So at my level, the training that I took here, I learned how to use the basics of it, which helped me a lot to further my education. So I have a front, I'm like I guess a step ahead of other people. They just don't get the technology at all. If I didn't have this, I wouldn't have this job. And I'm learning more and more, and hopefully I'll get more advanced as it goes along. One day I'll be able to create my own cubes, hang out with the core team eventually. Because I learn from them. Most people just go, give me the query. I don't. I go, hey, show me how to modify this query. Show me how to query the tables myself. So that's why I asked for the map. I'm one of the only ones that actually has the map besides those guys.
Nice. Cool. Appreciate it. Good job.
Good job.
Good job.